Today we'll be going over byte stuffing in the link layer frame. So why is byte stuffing needed? Sending data in the Ethernet frame or the link layer, we must have some way to tell when a frame begins and when a frame ends. This is typically done by putting a byte at the beginning of the frame and at the end of the frame so the frame can be recognized by the receiving hardware. It would make sense to use special characters that wouldn't normally be sent to serve these purposes. Ethernet uses the start of header or SOH character for the beginning of the frame, which is ASCII 2 character number 1. And it also uses the end of transmission character or EOT character for the end of the frame, which is ASCII 2 character 4. Now, there's obviously a problem if we want to send either those characters or other special characters as data. The solution is to encode SOH, EOT, and other special characters for unambiguous frame transmission. The sender will notify the receiver of the specific character encoding in the frame preamble. So essentially all byte stuffing does is remove any of the false SOH and EOT from the data before the frame is sent. After it is received, the receiver will go through the data and revert any byte stuffed characters to their original form. So here's our example. We have been given the following byte stuffing scheme. SOH and EOT are framing characters. If Ethernet style byte stuffing is used to transmit data, what is the byte sequence of the frame, including the framing characters? I'm going to assume that all headers are included in the data. So really, this is all that we need to perform or to solve the question here. I like to start by kind of writing out systematically what it has told us. We know that the SOH and the EOT are framing our characters, so we could write it out in either form, and it's good to be able to submit back and forth. So the data that we're sending, or the total sent, is going to start with SOH, include our data, end with EOT. And the hex codes for that are going to be 01H, our data that we're going to fill in, and 04H. And then we'll begin working on stuffing our data as needed. Now, it's good to note that only the characters in the byte stuffing table need to be encoded. The rest are unchanged. So if we think of it programmatically, we'll look through our data. If the data is not in this table, or the byte stuffing table, then we can just write it out as is. So in this case, if we work through this pretty quickly, we see that so far we have the SOH, and then we'll look at our first character of data, which is 78H, and we can see that is the character X, and we still have our EOT. So if we continue and write that out in hex, we have 01H, our 78H, and we'll continue on. And we see that we've reached a special character. So we can look at this thing and say, hey, what is 04H? 04H is EOT. Is it in this table? Yes. And we'll need to encode that using this table. So we can write that out as escape Y is what it tells us to do when we reach 04H, which is EOT, as escape Y. So we can write that out that we've received so far. And we can also write out that becomes in hex, and I've parentheses for emphasis mind that this is a byte stuffed. So far we have 01H, 78H. What is escape? It is 1BH. And what is Y? It is 79H. So escape Y just becomes those exact characters, 1BH for escape and 79H for Y. We can now see that we've received an escape Z as our next character. We can look as 1BH, a special character. Well, what is 1BH? It's escape. Is it in this table? Yes. What is it? It's escape Z. So we can write out escape Z, again in parentheses mine, as 1BH. What is escape? It's 1BH. What is Z? It's 7AH. We can write that out there. So this is where, when I'm actually solving these problems, I tend to write it out like this to solve it a little bit quicker. And so that's really to translate exactly what we have that we can easily translate into hex for our solution. So we can write out what our beginning and end indicators are going to be. So write out SOH and EOT, and then in the middle is our data. And we can write out 78H is X, 04H is going to be EOT, and that's escape Y, so write that out, etc., until we get our full solution. And then it's very easy to translate these to the hex. Just, again, consult this table. X is 78H, escape is 1BH, Y is 79H, escape 1BH, Z 7AH, etc., until we get to the end. And so now I have an example problem for you to solve. That's going to be the exact same question, but with this following data. All right, thank you guys very much.